Hello everyone. In this lecture, we will be learning what is t-distribution, which is one of the type of sampling distribution. And secondly, when we define a statistic for this distribution, we will call it as t-statistics. It has a particular structure. So t-distribution and t-statistic needs the understanding of central limit theorem of the basics probability theory, and it's a very important and famous theorem which is mostly used in relation with the normal distribution. So while preparing this video, I am assuming that the audience knows the prior knowledge of normal distribution and central limit theorem. So we will start with the central limit theorem and statement in short, and then we'll switch on to what is the structure of t statistic and what is the t distribution. In short, we will learn what is t statistic, how it is defined, and secondly, how to do the basic calculations regarding t statistic and t distribution using statistical t tables. So let me share my screen. I hope my screen is visible to all of you. Let me proceed to the next slide. So here we have central limit theorem. So let's go through this theorem. So let capital Xi, where I will run from 1 to up to n, be n linearly identically independent random variables. So capital X1, X2, and so on up to Xn are identically independent random variables with the expectation of each and every random variable xi is equal to mu, and variance of each and every random variable xi is sigma square. So this is given. So if we consider the sum of all random variables, which we can treat as the linear combination of x1, x2, xn, then we have its expected value is equal to n into mu, and the variance of all the random variables in their addition will be n into sigma square. So if we want to standardize summation xi, then what we should do is we will be subtracting its expected value, namely n mu, and we will be dividing its standard deviation, namely n into sigma square. Okay, so one should understand that if capital X1, X2, and Xn are random variables, then their addition summation xi is also a new random variable. Okay, so if this is a random variable, summation xi is a new random variable, then if you subtract its average n mu from that, and if you divide by its standard deviation, namely square root of n into sigma, because variance is n into sigma square, so if we divide by its standard deviation, it will form a new standard normal random variable, and that new standard normal random variable we will be calling as capital Yn. It is just a notation. Okay, so here I would like to bring you into consideration that capital Yn is, we can write this random variable capital Y as summation xi. Of course, I will run from 1 to up to n, dividing by n minus mu. So what I'm doing, I'm dividing numerator and denominator by n. So in the denominator we have square root of n into sigma divided by n. So this implies is that capital Y is x bar minus mu upon sigma by root n. So this is the central limit theorem. So what central limit theorem says, that x bar is also a random variable which follows a normal distribution with mean or average is equal to mu, and standard deviation is equal to sigma by root n. Therefore, capital Y, which is x bar minus mu upon sigma by root n, is the standard normal random variable. So this is the structure of the distribution which is followed by x bar. So x bar follows a normal distribution with mean mu and standard deviation sigma by root n, and therefore y is a standard normal random variable. Okay, so with this we will go ahead with a type of distribution that we want to learn over here, and that is t distribution. Okay, so let me just start with t distribution. So this distribution is used mostly if sigma is unknown. So what is sigma? So I hope everybody knows that sigma is the population standard deviation, and the corresponding sample analog is S. So this is sample standard deviation. So one should understand that sigma and S are analogs to each other. Sigma is population parameter and is the sample parameter, namely sample standard deviation. Okay, so when t distribution is used, it is used to deal with the inferences about the population mean. Okay, so if the population standard deviation is unknown, we will use t distribution. So this is basically the distribution and the experiments where sigma is no more reasonable than the knowledge of the population mean mu, and if sigma is unknown, the natural statistic one should consider to deal with the inferences on mu is t. So how this t statistic is defined? So t statistic is defined as, so what is meant by the word statistic? Statistic is the linear combination of random variables. So t statistic is defined as x bar minus mu upon s by root n. So here let me just correct myself. If sigma is unknown, it is very important. If sigma is unknown, then we will be using t distribution. So how t statistic is defined? It is x bar minus mu upon s by root n. So one should understand in central limit theorem there is sigma over here in the denominator. But if sigma is unknown, we will replace the role of sigma by s in central limit theorem, and it will give rise to a new random variable or a new statistic, we will say, and we'll call it as t. So what is t? T is x bar minus mu upon s upon root n. Okay, so s is the sample analog of sigma. So if the sample size is small, s square fluctuates from sample to sample, and t distribution deviates from the standard normal distribution. Okay, so in sampling distribution of t, we'll assume that the random sample from the normal population. Okay, so once we have understood what is t statistics, let's go ahead. So I'll just write t. Just now we have seen. That's very important note. So we define t statistic as x bar minus mu upon s by root n. So same thing I can write as sigma into x bar minus mu upon sigma into s upon root n. So what I do, what I have done over here, I have multiplied by sigma and divided by sigma. So if this is so, then we can rearrange the terms and we can write as the numerator as x bar minus mu upon sigma by root n divided by s by sigma. Okay, so s by sigma is left in the denominator. So the same thing we can write as x bar minus mu upon sigma by root n. So that is there in the numerator, and the denominator is, we can write denominator as s square upon sigma square, and it is under the square root sign. So we can write it in this form. So what is this numerator? So now you can understand. You just recall central limit theorem over here. So x bar minus mu upon sigma by root n is nothing but y, or it is a standard normal random variable. So basically we denote standard normal random variable by z. It's a standard notation, and the denominator is s square by sigma square. But in the YouTube session on chi-square distribution, we have already seen that s square is having the definition is n minus 1 into s square by sigma square is chi-square. So chi-square random variable is defined as n minus 1 into s square by sigma square. So how we can write s square by sigma square? So from this we can write s square by sigma square as chi-square upon n minus 1. So I'll write here in the denominator, in the last step, just concentrate as square root of chi-square upon n minus 1. So what we have shown? So we have shown that t is the ratio of standard normal random variable, namely z, and chi-square in the denominator. Okay, so therefore we can conclude that t statistic is nothing but the ratio of z statistic and chi-square statistic. So t statistic comes with n minus 1 degrees of freedom. So those degrees of freedom are followed by the chi-square statistic. Now with this important note, let's see how t distribution looks like. So there are probability density function is the characterization of each and every statistic. So if I take PDF of t, it follows, actually it looks like a normal distribution, because t statistic is the ratio of z and chi square. So t distribution is same as the distribution of z. Both are symmetric about mean of 0. So this t distribution, its PDF follows the bell-shaped curve. So both z and t are following a bell-shaped curve. Then t is more variable since it fluctuations with respect to x bar and s square, whereas z values depends only on x bar and it changes from sample to sample. So t is more variable than z. Next property, one can say that the variance of t depends on sample size n and is always greater than 1. And as n tends to infinity, both the distributions, namely t and z, will become same. Okay, so as the sample size is going to increase and increase, both z and t becomes same. So let's now see how to make use of t tables to find out the t values in some examples. So let me just write down example 1. So example 1 is saying that find t value with degrees of freedom. So DOF means degrees of freedom to be equal to 14, that leaves area of 0.025 to the left. Okay, so this is my question. So just now we have seen that t distribution follows a bell-shaped curve, so it is symmetric with respect to mean 0. Now you have to find out t value that will lie on horizontal axis of the probability. This is probability density function, its curve, PDF of t. Probability density function. PDF stands for probability density function. Now, now the question is you to find out that t value that leaves 0.025 area to the left side. So basically, I should not mark it in the middle. So let me just rub this part. So I should mark that t value slightly to the left side, because only 25%, 2.5%, sorry, only 2.5% area is there on the left side of that t value. So the question is, what is this t value? If you have the left hand area, that t value to be 0.025. So if left hand area is 0.025, how much is this right hand side area? Total area under the PDF is 1. So this is one of the very important property of probability density function. Here I am assuming that the audience knows what is PDF and CDF of any distribution. So total area under any probability density function is 1. So if total area is 1, what is this right hand side area after this t value? that will be 1 minus 0.025. Okay, so the right hand side area is 0. So right hand area is equal to 1 minus 0.025, and that is having the value 0.975. Okay, so this area will be 0.975. Let me just tell you now how to make use of statistical tables. So let me just open my PDF of statistical tables. So here you are having t-distribution table, and now we are having 14 degrees of freedom, right? So the degrees of freedom is given in the example. So degree of freedom is 14. Now for 14 degrees of freedom, if you just concentrate on this graph of t table, I already told you that t distribution follows a bell-shaped curve. So this part is shaded. So let me just expand my page. If you just concentrate on this table, the right hand area to the right side of the t value is shaded. So what does it mean? The tabular convention is that the table and the tabular values are going to give you the t values and the alpha values that are given in the table. So alpha is basically the area after that t value under the curve. So it's area under the curve after that t value. Okay. So I have to find out that t value. Okay. So if I say that this value is t, then because of symmetry of this particular t distribution curve, this value will be minus t. And because of symmetry, again, I can say that this area is also alpha, because right hand side area is alpha, then left hand area towards the left side of minus t is also alpha. So in our question, this is 0, this alpha is 0.025. Okay, so what is that t value whose area after that t value is again 0.025? So one can see this from the table. So let me just scroll up this table because we have to do it for 14 degrees of freedom. Just rub this part. Now for 14 degrees of freedom, how one can see? So one can see that for 14 degrees of freedom, I mean I'm over here, and for alpha is equal to 0.025 because this is 0.025 and therefore minus t alpha. So this is 0.025. So that t value will be the intersection of that row and that column, which is 2.145. So here I will say that this value is 2.145. Therefore, this t value will be the negative of this. So therefore, the answer to this question is, what is that t value that leaves the area of 0.025 to the left? So what's the answer? The answer is minus 2.145 is that t value, okay, which leaves 0.025 area to the left of that. Okay, so the answer is minus 2.145. With this, we will stop and we'll meet in the next lecture for F distribution. Thank you.